You are watching the Daily Science Journal, where we simplify complex science topics for you. Subscribe to us. It's absolutely free. Can you stop time? Not by magic, but by simply looking at it? Sounds impossible, right? But in the strange world of quantum mechanics, that's exactly what the Quantum-Zeno effect suggests. The more you observe something, the more you can freeze it in place. Today, we're going deep into this mind-bending phenomenon. How it works, why it's so mysterious, and what it might mean for the future of science and technology. Stick around as we tell you about an effect that might just make you question reality itself. Before we dive into the Quantum-Zeno effect, let's set the scene. In the quantum world, particles like electrons and photons behave in ways that defy our everyday logic. They can exist in multiple states at once, what's called a superposition. But here's the twist. When you measure or observe them, they collapse into a definite state. In other words, observation changes reality. This is where the Quantum-Zeno effect takes the stage. It's the idea that if you keep checking on a quantum system over and over rapidly, you can prevent it from changing at all. Like constantly asking, "Are you there?" until the universe gets too nervous to move. So why is it called the Quantum-Zeno effect? The name comes from an ancient Greek philosopher, Zeno of Elea, who loved to create paradoxes that mess with our heads. His famous one is the arrow paradox. It goes like this. If you observe an arrow in flight at every instant, it's motionless at each moment. So logically, it never moves. Of course, in our everyday world, arrows still fly. But in the quantum world, things get stranger. Here's the science. In quantum mechanics, systems evolve over time according to the Schrödinger equation. But when you measure the system, you collapse its wave function into a fixed state. If you keep doing that rapidly enough, you repeatedly force it back into that same state, like hitting the reset button before it can change. It's a bit like a pot of water that refuses to boil if you keep lifting the lid every half second. You're interfering so much that the natural process can't progress. The Quantum-Zeno effect isn't just theory, it's been tested. In 1990, scientists at the National Institute of Standards and Technology trapped beryllium ions and used lasers to measure their quantum states repeatedly. The result? The more often they checked, the slower the system changed. They actually froze the ions in place just by observing them. Similar experiments with cold atoms and superconducting qubits have confirmed the effect, showing it's real and not just a quirky thought experiment. Here's where it gets truly bizarre. This isn't about human eyes looking at particles. In physics, observation means any interaction that counts as a measurement. Even a machine or another particle can observe something in this sense. And in quantum theory, that interaction changes the outcome. Which raises big questions. Does reality only exist when measured? And if so, who or what is doing the measuring? That's where the philosophical rabbit hole begins. Just when you think you've got it figured out, quantum mechanics throws another curveball. There's also the Anti-Zeno effect. In this case, frequent observations can speed up the change instead of slowing it down. Whether you get the Zeno or Anti-Zeno effect depends on the system, the timing, and the nature of the measurement. It's like reality has two modes, freeze frame or fast forward, depending on how you watch it. You might be wondering, besides bending our brains, what's the point? Well, the Quantum-Zeno effect could have huge implications. In quantum computing, for example, we might use it to protect fragile quantum states from decoherence, basically keeping qubits stable longer. In medicine, some researchers even think similar principles could one day help control biochemical reactions at the molecular level. Ultimately, the Quantum-Zeno effect is another reminder that the quantum world doesn't play by our rules. It blurs the line between the observer and the observed, raising deep questions about the nature of time, change, and reality itself. And maybe, just maybe, it hints that our act of looking at the universe shapes it in ways we don't yet understand. So next time you catch yourself staring at something, remember, You might be holding it in place without even realizing it, or speeding it up. Welcome to the quantum world, where watching isn't just passive, it's power. If you enjoyed this dive into the quantum Zeno effect, give this video a like, share it with your fellow science geeks, and subscribe for more journeys into the strange and fascinating universe we live in. Until next time, keep questioning reality